What's up, guys? We back at it again. It's June 12th, 5 p.m. I'm so close to finishing chapter 3 of CS app. I'm literally so close. Yeah, I have a little bit of floating point code left. Um, yeah, and then I'm done. Finally done with chapter 3. Uh, yeah. So close. So after finishing this right here, and then I'm going to get back to and finish it. So yeah, let's get into it. I want to do this crack me because yesterday's crack me was pretty interesting to me. So I'm gonna keep doing that right now. And I'm gonna do the lead code question, the water fill question, suffix prefix, right? And see how we go with that. Cool. So first I'm gonna download this. Um, which should be in here. Cool. It's a Unix file, and then what I want to do is I would want to share my screen for here, and then I have to cd into opt the homebrew Ghidra that, right? And then I have to go e Ghidra run Ghidra run. Mhm. And then that will launch the program. Cool. All right. Um, and then we will do a new project. We will do a new project. That is not shared. Right. Crack me two. Crack me two. Cool. Oh, oops, you can't see it. Right. So here we are. And then we will open the project. Crack me two. Cool. Huh. Then you close project. What is this active project thing then? It is not active no more. Bam. Open project. And this. Okay. And then I'll import file. And then I'm importing this, right? Boom, boom. Cool. And then now I should be open this. Analyze it, please. Don't exactly know if I wanted to analyze, to be honest. But let's look at the functions, I guess. Let's look at main. Deregister, frame dummy, main fun. That looks like a pretty interesting program. Anyways, let's look at main. Okay. So a lot of shit. Cool. All right, so let's analyze this, right? Let's try and analyze this. So this will be in, um, because you usually just return in main, right? Main void character, boolean. Wait, let's just try and run the program and see what's the behavior of the program, right? So let me just boot the Docker container real quick because I need that to um cool. So now I'm in Docker. Oh shit. And then I need to import the actual thing, right? Go to dashboard. To import the actual file. CrackMes. I'll CD into I'll CD into home. No CD into CS app. CD into CrackMes. And then I'll make directory CrackMe1. And I want to move keygen. How to move files. Wait, move files CLI. So I'll move keygen test into home CS app, CrackMe, and CrackMe1, right? What? Did I type it wrong? Keygen test.bin. What? What's wrong? You know what? I'll just do it in the GUI because the GUI never fails. What the fuck? What? Why can't I move? So move keygen test.bin. Missing file operand. Okay. So move keygen test.bin. Home, CS app, CrackMe's, CrackMe1. Okay. Move keygen test.bin. This is home directory. CrackMe's, CrackMe1. Boom. Okay. Now it's moved. Beautiful. So now it's just this. Okay. I'm sorry, you guys have no clue what the fuck I'm doing. Um, but I am doing something. Just trust. So the file is called easy AF, right? Cool. So I'm sorry. I should have shared it. So now I have easy AF. Crack me too. Boom. Enter the password. Nope. Okay. So it's something simple like that as well, right? Okay. So here. So I'm looking for a logic that will give me the password, right? Cool. So there has to be somewhere where it takes my input, which is here. Standard C and local. So local would be my input. Operator equal equals. So C var1 would be is equal, right? I believe so. Is passed. What is this supposed to be? Yeah, show me the decimal. No, it is equal, right? If it's equal, okay, hold up. O stream, local 48 would be the user input, right? This is some sort of standard string user pass. What the fuck is this local 68 shit? Hmm. Wait, let me undo everything first. 還原基本步. Okay. Hit me with May. 'Tyrann shit again. Local 20 is not used. String 68 is a 32 character long string. Huh? Now right here, you're C in 48. So 48 would definitely be user input, right? C char C variable equals to user input equals local 68. But what is local 68? Local 68 is right here. What is a string operator? And pass. Would the would the would the string just be pass? Oh, okay, I see. Now if we look here, right? Easy AF. If I just enter pass, there we go. It's done. Like, is that it? If I if I enter something else, nope. Terpasio. Pass space. It would still be pass because it's C in, right? Okay, so it's literally just that. It's this right here because it sets local 68 which is the comparison string, I would assume. The correct answer to be this is equals pass. Boom. If string is equals, it will become one, right? But if it's not, then this is string is not equals. If string is not equal pass, then it's no. If string is equal pass, so basically if string is not equals, right? But if string is equals, then it'll come here and it'll say well done, right? So I would assume pass is the only uh valid string. Um, yeah, is that about it? Is that pretty much it? Um, would that be basically what it is? Really simple keygen program. But there's a keygen. But I feel like there's no keygen though. I think it's just the C++ assembly made my eyes bleed. Wow, that was surprisingly easy, right? So it's not right. So I would assume it's what I'm thinking. Um, right. Okay, yeah, the program simply checks if the user inputs pass, right? You can see here. Program simply checks if the user inputs pass, right? Simple. Um, okay, that's pretty easy. Excuse me. How do I save one though? Like, how do I save it so that I don't have to do it again? Very easy. Can't I save it? Okay, I can't save it. Oh, but I can rate it though. Okay, I mean that's pretty cool. Um, I do want to do another one though, because that one is a little too easy, in my opinion, right? So let's go. You can see my screen, right? Yeah. Let's close this tool real quick. We're gonna open a new project called CrackMe 3. Okay, I have to make directory. Um, I'm gonna make directory and where? Home, CrackMe is all these hidden files, which I don't need to see, just that. Cool. CrackMe's and then make dir CrackMe 3. Cool. And then with this CrackMe 3, I will download another CrackMe. Let's do an easy one. Easy AF was that one just now. Let's do a higher quality one. All fours. Is the 4.5 one the one I did yesterday? Let's do 4.2, right? Oh, but this is x86. Is there a 64 one? This one's stack pointer. Okay, this should be pretty interesting. What's the difficulty though? It's 2.5. No, let's not do 2.5. Let's stick with one right now. You know what I'm saying? 4.2. Okay, this works, right? This is the one that we did yesterday. Oh shoot, you can't see. Um, right? This is the one that we did yesterday. Uh, this one is the one that I want to do now. So yeah, let's do it. Password login. Simple crack me, no patching, just figure out the password. Cool. Let's do that. Cool. So now it's all here. What I have to do is I have to import it. No, 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 no. I have to first go to the terminal. I have to CD back to my, yep, ls here, and then I will make their crack me 3. And then on my Docker, I will see it. And then what I have to do is I have to import this thing into here. Crack. Oh, Jesus. Boom. Cool. Um, Now if I cd into crack me 3, there is a crack me. Login failed. Cool. So it's just another one of these password questions. Um, what's small? Okay, yeah. So let's go to Ghidra, right? And we will do a new project. Crack me 3. Crack me 3. Boom. And what I want to do is import file. That's not what I want. That's what I want. Use what I want. Boom, boom, import, boom. And then I want to go to, what do these do actually? Holy debugging. Okay, that's kind of not what I need. What about this? Emulator, no. What about this? Version tracking, no. I just need the code and the code browser. Cool. Um, so I am now in the code browser, and then I will have to open. Oh, O is not open. Oh, man. Oh, man. Oh, crack me. Boom, boom. Analyze it, please. Boom. Cool. Analyzing. Let it run for a bit. Shouldn't take too long. And then let's look at the functions. Boom. Okay. Much like the other word. Okay, so this is a bit different because I see the check password, right? So let's look at the main first. And then check password would be the actual password, the actual function that we're looking at. Um, jeez. Okay, so this. All right, cool. So this is user input. I think that's the most because it's cin and the user input. So we can change that to user input. All right, cool. OS string. String local 38. Is that just making a copy? Mm. That's just the output, right? Just the output. These don't really matter. I just need to figure out what the thing is. Okay, so local 38. Okay, so let's check password. This is the one that I need to be looking at. Param one would be the actual string, would be the user input, right? I'm pointing to it. String local 48. Reverse, blah, 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 blah. Okay, this is a bit more challenging. Um, hmm. So I'm taking a parameter. I'm taking a pointer, a string that is a pointer. So this would be a pointer. Why is that a pointer? It takes a pointer to the string. So this would be return value. This will be result. Label. Mm-hmm. Is done label. L variable string dot length. These two, it's giving the same thing. So if length of input is equal to 7. So the first thing I'm seeing is the length of string cannot be equals to 7, right? Then 4, this would just be I. It's just a for loop. I plus plus for local 24. 24 would be also length of input, right? Same thing. If I equals to length of string minus 1, if I equals to the end, so this is the end of string, right? This would mean it's the end of string. Oh, oops. There's the last character. If it's the last character of string, then I'll append so I think here you're appending K car, right? Because you're appending K and then you're appending car. Local 48 is what? It's just a length check constant, right? Allocator, these two, I don't know what these are, bruh. Local 48 is here. Okay, if it's not the end of string, then what would this be? Right? You're reversing. So you're reversing the string. Could just be a random string. Like this could just be a random empty string, honestly. It could be, right? So if I am going to write a thing for this, like the 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 file would the function would probably look something like would probably look something like now you see both, right? Would probably look something like in wait, no, check password. And then it takes some sort of pointer. String. I should have that, no. Include standard I standard lib. That'd be it. Okay. IO stream. Include IO stream. What is a standard library, bruh? C standard lib. Okay, let's try it. So it's C standard lib, right? And tell me it recognizes, please. It doesn't? No way. I thought it is a type. What the fuck? String type not included in C standard lib? Oh, okay, whatever. Okay, now it should work, right? What is it not? The fuck? Okay, finally. Okay, beautiful. Cool. All right. And then just do this. Cool. And then what it should be in if input dot length is equals to 7. What does must have a class type if dereferenced. Well, it's a pointer to a string. I don't understand what's going on, to be honest. I'll only enter this if it's equals to 7. Why is this giving me problems? But it has what? Okay, just give me that then. Okay, whatever. Just passing the string. And then if I is equals to input dot length minus one, then what I would do here is see there is a random string here. String random is random string uninitialized. Um, that's what it is. String at 48. This one, I don't know what the fuck this means. So you're initializing a new string here? That's DEC and 25? Or would it just be DEC? Is that what it means? This one, I feel like this is the only part that I don't really know. This one I don't know. This one I don't know. If still within this for loop, right? There's the PC var too. And then random will also equals to PC var 2. After this, you would go reverse. Which beginning and which end? Yeah, I don't really know about this one. I need to look at the write-up. Put this together. Mhm. What? So it is DEC. So it actually is DEC. Oh my God. Wait. Wait. So it is DEC. Okay. Else to return zero here, right? Uh-huh. And then I don't know what the fuck this allocator does. What the fuck? Shit. Okay, I mean, so now I know the answer. Oh my God. Okay, well, I did not get that. What the fuck? Okay, fine. Not a big deal. Not the hugest of deals. Dude, fuck off with your Microsoft bullshit, man. What exactly am I sharing right now? Okay. Mm. Trying to download a virtual machine of Windows so that maybe I can like play games or some shit, you know. Okay, that question was very, very difficult, if I'm being honest. So difficult, man. Okay, whatever. Let's do lead code now. We know the one that we want to do, which is the water one. Trapping rainwater. Yep. Yep. Um, so oh, so I want to refer to what I want to refer to is the product except itself question, right? Because um that uses suffix and prefix, right? This one. Cool. It's trap. This is what is it? Right? Mm, cool. Um, okay, so I have prefix. There should be some, right? I have two. I want to find, my God. Oh my God, dude, CS. It's not simple, guys. It's really not fucking simple. A brute force solution. I want to try the brute force solution first, which is, right? To find the greatest on the left side. Can I learn this? Yeah.
Hey everyone, well, hey everyone, welcome back. And we've got some more neat code today. So it's been a while for me. Sorry, I've been pretty busy, but let's today solve leak code 42, trapping rainwater. So we're given an integer array representing the heights of certain elevations or whatever. See, this is 1 unit right over here. This is roughly 4 units, right? 1, 2, 3, 4. And this is another one, right? So when you count all of those, you get a total of 6 squares, right? So the output is 6. This can trap a maximum of 6 blocks of water. So with a picture, it's pretty easy, but how do you know, right? Like what's the algorithm to determine how much each position could trap, right? Like for example, this position is the first one, right? So there's no boundary on the left of it, right? So no matter how much water we would add over here, it would all just spill to the left. And the same is true for this position, right? No matter how much water we put on top of here, even though there's a right boundary over here, right, there's nothing on the left of it. So all the water is just going to spill out to the left. So it's not going to trap any water. But you can see in the third position, we are able to trap exactly one block of water. So what's the algorithm to determine why is it one, right? Because we care about the height because we want to know how much water. And it's actually pretty simple, right? Take a look. So here we have one block of water. What if I added a second block of water? Well, we can see that there is a boundary on the right. This is good, right? But what about the left side? There's no boundary over here, right? Meaning any water I add is just going to spill out. The boundary only has a height of 1. So we're seeing that the height on the left is 1, the height on the right is 2. So we need to take the minimum of that. We need to take the minimum of 1 and 2 because that is our bottleneck. That is what's determining exactly how much water we are able to trap per position, right? For every single position, we need the max height on the left and the max height on the right, left and right, and then we need to take the minimum of those two. Let's take a look at this position. Clearly, we can't trap any water in here, but why exactly is that the case? Well, when you look at the right position, right, in the entire right section, the maximum height is a 3, right? So that's good. 3 here. What's the maximum height on the left side? It's a 1, right? This position is a 2. If we take the minimum of 1 and 3, we get 1. So that's our boundary. That doesn't mean we can trap any water here. We can trap 0 water here. The reason is because the actual calculation is we're going to take the minimum. We're going to take the minimum of the maximum left height and the maximum right height. We're going to take the minimum of those two. And we're going to take the height that we're currently at, right? So let's say h of the index I that we're at. So this is the equation we're going to use to determine every single position I, let's say this is our I position, right? So you can see I is in this equation. This is going to determine how much water we can trap in position I. So we know the minimum of the max of the left and right, right? Because the left was 1, the right was 3. The minimum of those is just going to be 1. And h of I, so the height at position I is 2 over here, right? 2. So we're going to take 1 minus 2. That's actually going to give us a negative number, right? That's going to give us negative 1, but we know we can't trap negative water, right? So we're always going to round up. We're never going to use negative numbers because it doesn't really make sense to trap negative water.
Okay. Um, so if I start with 0, and I'll compare it to the right, right? Is there a point in starting in 0? Because even if this is starting up here, there's no way I put any water here, right? Yes, so there's no point in really starting in 0, right? So I can just ignore this. And then now I have to calculate the index of each the maximum on the left and maximum on the right. Maximum on the left would be, how would I get that? I iterate through the elements on the left, and then I iterate through elements on the right. Right, it could work, right? If height j is bigger than max left, max left will be equals to max left, and height j. And then this will duplicate. Oh, then this will be the same. This will be j equals to I plus 1. J is smaller than I size. Max right, max right. So now I have max left and max right. And then what I want to do is res is plus or equals to the minimum of max left and max right, right? And that's actual height. Dream overlay, my soul is born. This has to be maxed between this one and 0, right? Because it cannot plus negatives. Let's say it's this one, the max on the left is 1, and then this will be 3. Minimum will be this, so 1 minus 2, it can be nothing. Let's say if it's here, then the maximum it can hold will be 1. Yeah, that makes sense. Okay. And then after this, I should be able to return result. Fuck. So ON squared does not help. Um, Afro blue. Dream overlay. My soul is born. I think I can optimize this by moving L as soon as I discover a bigger element, right? Equals to 2. While L is bigger. Find the global. Oh, so this is brute force, right? And the brute force does not work because it's too fucking slow.
Over here. So
Cool.
really, since the solution is negative, that really means that we can trap 0 water in this position. But let's just move to a couple more positions before you probably get the idea. So over here, right? In this position, the height is 1, right? And the max height on the left is 2. The max height on the right is 3 again, right? So we take the minimum of 2 and 3. So we're going to get 2, right? 2 is the minimum, and height of I is 1, right? The height at this position is 1. So that means we can trap exactly 1 water in this position, right? Clearly, that is the case, right? We're trapping 1 unit of water. And basically, if you did this exact same calculation for every single position, including this position, you'd get the appropriate water count. So this position would give us 2 units of water. This is going to give us 1. These are going to give us 0. This is going to give us 1, and the rest are going to give us 0 water that we can trap. Once we take the sum of all of those, we are going to get our answer 6. So now let me actually show you the efficient ways to solve this problem. Okay, so I'm going to show you 2 different ways to solve this problem. Both of the solutions are linear time solutions, right? So big O of n is going to be the time complexity.
Crazy.
The solution, but the first solution I show you is going to actually require big O n of memory as well. There's an actual optimization you can do with 2 pointers to reduce the memory from linear memory, big O of n, to constant memory. So I'm going to show you both of the solutions, and it's actually not a lot of code. The code is actually pretty easy.
Come back to the product of array thing. This one, right? Dream overlay. My soul is born. I find the greatest element. Right. Let's try and copy image. Right. And then we can go into slide. Right. This one paste this. Okay, cool. How do I zoom in? Right. I'm thinking if I whatever. So if I find the greatest element, right, then then oh fuck. Go, bro. Zero. Zero. Outline. Is this it? Wait, then all of this I will count, right? Because I just do greatest minus current height. Same for here. Greatest minus current height. And these two, right? So I'll have all of this. Zara, was om zero.
And so for every single position, right, to know how much water we can trap at index I, we need to know what's the max left and right height. Hey, Sam.
So,
啊，JB 完了。
唔係識
This position, the max on the left is going to be three right over here, and the max on the right is going to be three right over here, right? So we need to be doing that calculation a lot. So we can actually make an array and then store that calculation for us so that we only have to do it a single time each. So
What the
first,
fuck?
we can scan through the array, right? Just go iterate through the entire array, calculating every single max left position, meaning for this position, what's the max height on the left of it? Well, there aren't any heights on the left of it, so it's going to be zero. What's the max height of this? Well, the max height is zero, right? That's the only height that came before it. What's the max height on the left of this? Well, it's a one, right? So we can do this in linear time, big O of n time. So I'm just going to do that, right? What's the max height on the left of this? One. Max height on the left of this. We have a new max, it's two, right? We just keep track of what the current max.
That's what I was thinking as well. Okay. I guess. Cool. So, but he's using an array instead. Right. want to have a max left in as well. Primo relay, my soul was born. Da, na, 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 na. I'll have a max right vector as well. Right? And how do I do the max right?
Right, so we calculate when we iterate through this in reversal because there's nothing on the right of this. Next, it's going to be one.
Dream over. Right? Cool. I think that's fine. So I have at index I what the max right is and what the max left is. Right? And then I already have the formula to calculate the trapped water, which is the minimum of, no, there's no minimum. Is there a minimum? Yeah, there is a minimum. It's the minimum with these two minus height I, but then it's the max of this, right? L L L L R R R R. Okay. But I'm sure there is a better way to do this.
One, we trap in this as well as zero. We can trap, and we can do that, remember, with a zero. And so expected this time we're not going to need any of this extra memory that we just allocated. We're actually going to do this. We're going to do this with 2 pointers. So initially,
Right, it's something like this.
Pointer over here. I'm going to have my right pointer here. So the right pointer is going to be all the way at the end of the input array. So we're going to have our 2 pointers initialized. We're also going to have 2 variables, max left and max right, which are going to be keeping track of the maximum left pointer and maximum right pointer so far. So
yeah, that's what I was thinking.
Zero, so
that's what I was thinking.
0. You can see right is initially 1. So the max on the right.
That's exactly what I was thinking.
1. So now we are going to have to update our pointer. Now, which pointer are we going to shift? We're going to take the one that has the smaller max value. So right now you can see max left has 0, max right has 1. So we're going to shift the smaller one, which is left. So we're going to
it's something wild.
Shift it. So now our left pointer is over here. And just FYI, we know that we can't have any water stored on the endpoints, right? On the left and the right positions, we can't have any water because they're endpoints, right? They can't contain any water. But this position technically can have some water. And how are we going to determine that? Well, we're going to take how much water this can contain, right? We're going to take the max left value that we have in our variable right now, right? How come we don't need the right value? Well, I'm going to show you. So this is the part that you kind of need to notice the trick, I guess, right? So we're in this position, right? Now, remember originally we wanted the minimum down here. You can see we wanted the minimum of the max left and max right. Well, we know what the max left is so far, right? The max left is 0, right? That's what's over here. Now, we technically don't know what the max right is, even though this variable says 1. Yes, so far it's 1, but we know that the max right could actually be 3, right? That's what the true max right is of this position, right? Because there's a 3 over here. So why is it that we don't need that value? Because remember,
你都好中意去啲樓上 salon 啊？我想問呢間 salon 係咪 HBBH 揾開俾你啊？剪開藝人嗰啲咧，係咪特別好嘅，特別貴嘅？真係唔知喎。係咪我同人講話我係 HBBH 老公嘅老 best 會有七？唔使啦，你留咧，係好熟咁啊！現金付，佢唔落雨嘅，膊頭有花嘅，有冇人都？可能啲人唔想打波咧，落大雨唔搭火車冇啊！佢就算有啲人嚟咧，佢都係揾佢啲 friend 嚟，即係因為佢係唔係嗰啲你想打嗰啲咧，要星期一堂，即係佢係 regular。你試下屈一屈入去大埔頭睇下實唔實佢哋。
we want the minimum of the max left and the max right. Now we clearly know that the max left is 0, right? So it's smaller than what's even at this position, right? And we want the minimum of it. So no matter how big this value is, right? Right now it's a 3, it could be a 10, right? It doesn't matter how big it is because we want the max of the left and the right. And we already know that the left is pretty small, right? It's 0. So it doesn't matter what's in all of these values because we know that the max left is our bottleneck, right? Remember, we shifted our left pointer from here to the next position because left was smaller than right. That's why we shifted it. That's how we're able to calculate the water that's trapped in this position without knowing what the max right is. So with that being explained, let's actually go through this so we can get to the code. So what's the amount of water that we can trap over here? It's actually 0.
Okay, hold up. Hold the fuck up. So I don't have this. Bát pa take more. 榴蓮 K 風走過。喂，
because the max left, which is the value that we need, is 0, right? So 0 minus what the actual height is in this position is 1. We know that's going to be a -1. We don't count -1s, so we're not going to use that. So we're going to say that 0 water can be trapped here. But you can see, look, this is a 1, right? Our left pointer is here, so we can actually update this. We can cross the 0 out. Max left is now actually going to be 1. So now we're actually at a dilemma, right? Because take a look, our max left and our max right are both 1. So it doesn't really matter which one we shift. Let's just shift the left one again. So we're shifting our left pointer over here now, right? And since they're equal, this is going to be the bottleneck, which is left pointer and the max left, and it's 1 so far. So no matter how big anything over here is, we know that 1 is going to be the bottleneck. We're going to do 1, which is the max left pointer or the minimum of the max of the left and right pointers, right? So
Yo.
we're going to take that 1 minus the value that's in this position.
請問俾如果有得俾揀，你揀西餐定係中餐啊
中文唔係咩？
？Eat at home，
都唔係話中咩？個西餐俾人搞唔掂啊！
唔好理啊，總之中餐西餐俾你揀。
我冇所謂，
No, pick one。
我胃冇乜所謂，細咯。
Okay.
The height of the index line, which is 0. So that's going to give us a water level that is 1. So that means in this position, we can store 1 block of water. So basically, I'm running through the algorithm with 2 pointers. So I'm just going to quickly go through the rest of what this example would be. So again, we're going to shift our left pointer because left and right are equal. So it doesn't matter which one we shift. We're shifting the left one over here. So now to calculate how much water would be stored here, we're going to take the max left pointer, which is 1, and subtract from it.
I don't really understand, to be honest. Right. L if height max L is smaller than height max R, plus plus. Let's just use L and R. If it's equals, else, is that it? No.
Right, vector, which all these people are separate. Is all present, that would left something to be water.
Yes.
So. Felt
Drop.
you have left, which
If left max is smaller than
Fuck all the Zai is my favorite song.
so if we get to,
Oh.
let's say, if our left max would
Oh, this is so good.
Oh, it also has, I have to also save the video now.
Also.你今晚去邊啊？今晚去哪裡？
打波
將
最
be
好。
之後 hashtag jealous，因為 jealous of you。喂，點解唔 work 嘅my sense？
哇，我唔 like get 啊，what the fuck？Well, L is smaller than R. Oh.
right, and so in
If left max is smaller than right max. If left is smaller than max R, then L plus plus L. And then left max will be max L will be equals to a maximum of oh man. Well, is this it? I have no
Else
clue.
conditions we're gonna be doing.
I don't get it. Oh,
我喺泰國食過飯，但我會睇下個牆濕唔濕咯，即係可能濕，不過應該都濕嘅仲係，咁所以你當住係雲海先。
別派人來找我，訂票單人去北非看駱駝。So I should move. Okay, I have to go eat. I'm gonna, yeah, I have to go eat. So I'll call it a day here. Peace.